Hey everybody, this is part 2 of the dilations lesson examples, and this lesson is specifically for team graph paper. And I know team graph paper, I've been voicing my concerns about being on team graph paper, but look, now my 2-year-old daughter, she's concerned too. She's concerned that you're also on team graph paper. Kyla would love it if you would transfer to team no graph paper, because it's mathematically more precise and easier, and I can demonstrate why at some other point. But in the meantime, while you're on team graph paper, Kyla's scared. Anyway, Kyla, we need you to shrink down a little bit so we can do some math examples. It'd probably be effective if Elliot was small too. And here's some team graph paper problems for you. First thing I want to do is I want to graph y equals 3x squared. And if we use this chart that we had yesterday, or not yesterday, earlier in my lesson as a guide, when you have a number outside the function like we do in this particular case, that is the mark of a vertical dilation by a factor of b. So that's 3 in this case. So what we have is a vertical dilation by a factor of 3. Okay, so if I'm on team graph paper, I'm going to do this using graph paper. It's easiest for me if I have the original points at least marked in there. So I have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then we're essentially, when you are doing a vertical dilation by a factor of 3, you're essentially multiplying all of the y coordinates by 3. Oh man, this gets confusing. I urge you, please don't be team graph paper. Be team non-graph paper. But, alright, if I'm going to multiply these by 3, and I guess I need to use a separate color, this currently has a y value of 1, but if I multiplied it by 3, that would be 3, so it would move up to here. This point currently has a y value of 1, but if I multiplied it by 3, it would move up to 3. This point currently has a y value of 4. If I multiply that y value by 4, it becomes 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing over here. This has a y value of 4, so if I multiplied that by 3, it would also be 12. So I have these points, and then I connect the dots as best you can. So it went through 0, 0, this point, that point, and was heading up. And the other one, ooh, same thing. Okay, and that is how you would handle a vertical dilation by a factor of 3. Example number 2 is what happens when we have this this function business but divided by 4's on the inside. Well, if we use this chart as a guide, that's just like this divided by a, and when it's divided by a, that is a horizontal dilation by a factor of a. So I have, and the a is 4 in this case, so we are looking at a vertical dilation by a factor of 4. So I take my parent function in this case as my square root graph, y equals square root x. Those have key points at 0, 0, 1, 1, and 4, 2. And because it's a vertical dilation by a factor of 4, that means that you're multiplying all of the x coordinates by 4. So this had an x coordinate of 1, but if a vertical dilation of 4 means that it would move on out to 4. Or another way of looking at it, instead of going up 1 and over 1, it's going up 1 and over 4. Then, this one had a y coordinate of 4, or an x coordinate of 4, but if I multiply that x coordinate by 4, it would become 16. So I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. and my graph would look like that. Okay, so that is a team graph paper approach for number 2. And once again, everybody, I strongly urge you at this point, pause this video, just stop it right now. Go watch team non-graph paper. Watch the first 2 examples. See how much easier it is when you work these problems just by looking at the coordinates. It is going to be easier on your brain. I trust you. Scared Kyla. She's worried about you folks. If you're going to be really stubborn and insist on you must be team graph paper, it's okay. You will get the right answer. It's just more work. And I do have this third example. It's actually completely worked out already because I explained it on in my first in the non-graph paper lesson. But essentially, if I have this g of x, I want just some g of x, I want to write an equation that has a vertical dilation by a factor of 4, a horizontal dilation by a factor of 3, left 6, and up 9. Well, use this as a guide. A vertical dilation by a factor of b means that there's a b out front of the equation, and a horizontal dilation by a factor of a means that inside the function you are dividing by a. So with this, the vertical dilation by a factor of 4, I multiply the function by 4, and it does need to be called g of x here. A horizontal dilation by a factor of 3, I divided the inside of that function by 3. Because of the left 6, on the numerator of that function would be x plus 6. So that's the same as the h here. And then for that k on the end, it's going up 9, so we have a plus 9. Okay, well that's it everybody. And once again, let me show you the picture one more time because it's really cute, but it also serves a purpose. Kyla worries about people that are going to be on team graph paper. She understands that it's going to be less accurate than being on team non-graph paper. So if you watched this video and you're like, okay, I kind of like being on team graph paper, try out team non-graph paper video. It's great. And check this out. When I try to make Big Elliot, totally hidden behind Kyla. That's not cool. So let's make small Kyla. So we have Big Elliot. There he is. Have a great day, everybody. I'll see you sometime on the day on Wednesday. Bye-bye.